So, our final talk is to be given by Dr Krishnaraj Rathod from Queen Mary, University of London.
Okay. I'd like to start by thanking the organising committee to giving me the opportunity to present our research, which is investigating the impact of sex on cardiovascular function and inflammation. There's a number of observational studies suggesting lower incidence of cardiovascular disease in premenopausal women, and this protection is likely to be due to the female sex hormone. Another important point is that cardiovascular disease is characterized by endothelial dysfunction, and this phenomenon is thought to be brought about by systemic inflammation, which plays a key role in cardiovascular disease. We have a number of different models of measuring endothelial reactivity, and using these models, evidence suggests that females respond better in terms of endothelial reactivity compared to their age-matched male counterparts. But what's not been determined is whether there are differences in the capacity of systemic inflammation to induce endothelial dysfunction between the sexes. We therefore decided to investigate the impact of sex on inflammation-induced endothelial dysfunction in healthy volunteers. We did this using a model that's been well validated and used a transient inflammatory model. Our primary endpoint was ultrasound-based flow meter dilatation, which uses reactive hyperemia, and this was done using international standards. Now, one of the first times this model was used was by Hingorani and colleagues in the year 2000, where they measured reactive hyperemia, and what they found was 8 hours after giving the typhoid vaccine, there was a reduction in the FMD, or endothelial function. This was transient because 24 hours later, this went back to baseline. This is the protocol used by Hingorani and colleagues, and it's the same one that we used. So on day 1 at 4 o'clock, we measured their FMD, took some blood samples. On the second day, we gave them a typhoid vaccine in the morning, and then 8 hours later did the same measurements as day 1. 24 hours later, to look at resolution, we measured these again. Some of the female volunteers were on the oral contraceptive pill, and all the women were recruited at the same time in the menstrual cycle, which is in the middle, because we know that the levels of estrogen peak at this point. Now look at the results. So as you can see in both groups, they were well matched for age. We did see some differences, as has been previously published, so lower BMI and systolic blood pressure in the females, but overall there were no other significant differences. The first thing that we did was to look at the systemic white cell count, and what we found was just like Hingorani and colleagues, both in men and women, there was a significant rise to a white cell count 8 hours after the vaccine, which then subsided. We looked at the typhoid titers using the ELISA, and we didn't see any significant differences between the two groups. Looking at the primary endpoint now, so FMD, similar to Hingorani and colleagues, we saw a trend towards a reduction in the FMD 8 hours after the vaccine, which went back to baseline 24 hours later. This matched the white cell count. But what was really surprising to us was that in the women, instead of seeing a fall, we saw a significant increase in the FMD response, which then started to go back to baseline 24 hours later. Now, this study was powered to see a statistical difference between the sexes in terms of a change in FMD 8 hours after the vaccine compared to baseline. And what we saw was that in the men, there was a reduction in this endothelial reactivity after the vaccine, whereas in the women, there was a significant improvement. So the next thing that we needed to make sure was whether the smooth muscle cells had any role to play in the FMD response. So we used glycerol trinitrate as a direct nitric oxide donor, and what we found was there was no differences in the response to GTN in either sex over the 3 time points, suggesting that it's likely that the responses we saw were at the level of the endothelium. So why are we seeing these differences between the sexes? Well, we then decided to look at the key activation state markers on the leukocytes that are involved in the inflammatory response. And what we found was looking at CD162, 62L, and 11B, there was a significant suppression of CD162 in the females compared to the males, and a trend towards a reduction in CD62L. So it suggests that although there are no changes in the absolute cell numbers, there might be some changes in the activation states. We therefore decided to carry out a second study, which I'll call the blister study, to look at the cellular responses between the sexes, and to characterize this in a bit more detail, we use cantharidin. So cantharidin, when applied to the skin, forms a blister, which collects fluid, leukocytes, chemokines, and cytokines, which we can harvest and look at in a bit more detail. So we had 2 blisters, a 24-hour blister, which could represent the acute phase of inflammation, and a 72-hour blister, which could represent the resolution phase. Looking at the demographics again, These were similar to the typhoid study, lower BMI and systolic blood pressure in the females, but they're well matched for age. So we're really surprised by the results. So if I show you this table, which shows all the blisters formed at 24 hours, both sexes had 16 blisters which were present. But interestingly, and in contrast, at 72 hours, in the females after the 16 blisters, 9 had resolved at 72 hours, leaving only 5 there. This immediately suggests that the time point of inflammation and resolution is probably earlier and faster in the females compared to the males. If we now look at the content of the blister fluid, we can see that the differences in the time point is evident by the significantly lower volume of fluid in the females at 72 hours compared to the males. We saw a trend towards a reduction in the total cell count. This wasn't statistically significant. But we were interested in the actual different types of cells because we know that neutrophils play a key role when there's an inflammatory stimulus present. Disappointingly, we didn't see any differences between the cell count in either time points. But as you can remember from the typhoid study, it was the activation state of the cell, not the actual number of the cells. And looking at this, what we found was a significant dampening of CD162 in the females compared to the males, a reduction in CD62L, and a trend towards a reduction in CD11B in the females compared to the males. The next cell we looked at was the inflammatory monocytes. And here we started to see a significant reduction in the total inflammatory monocyte count. And again, looking at the activation state, there was a reduction in CD162, 62L, and now CD11B started to become positive. So why are we seeing these differences in the activation states of the cells? Well, this shows a time curve of inflammation showing the roles of neutrophils and monocytes. And what we know is as soon as an inflammatory stimulus is there, neutrophils start to release pro-inflammatory mediators, leukotriene B4 prostaglandins. But at the same time, neutrophils also release a number of lipid mediators that cause a conversion of the pro-inflammatory monocyte 1 and a class switch to monocyte 2, which are involved in resolution. And these are carried out by specialized pro-resolving mediators. And there are a number of these SPMs, which are derived from eicosapentaenoic acid and docosahexaenoic acid. And using liquid chromatography and tandem mass spec, we're able to characterize these in a bit more detail and understand the mechanisms. So pictorially, this is simple because each dot represents all the levels of pro-inflammatory and resolving mediators for each individual. So the females are represented by the green dots and the males by the blue dots. And immediately you could see that there's a difference in the populations of these two, suggesting that the levels of the inflammatory and resolving mediators are different. Now, these were measured at the 24-hour time point because we didn't have much fluid at the 72-hour time point, and also it represents the resolution kinetics. Looking at this in a bit more detail, we had a significant higher levels of D-series resolvins in the females compared to the males, and a trend towards high levels of the merisins, and these two are the resolving mediators involved in the conversion of the monocytes M1 to the resolving monocytes. We also looked at the inflammatory pathway by looking at leukotriene B4, and what we found was there was a significantly higher level of leukotriene B4 in the males compared to the females, and in this field you're able to characterize all these mediators as a group to look at the resolvins compared to inflammatory mediators, and what we found was the ratio of the resolving mediators compared to the leukotriene mediators were higher in the females compared to the males, suggesting that females might have better and quicker resolving power. At this point, we decided to go back to our plasma samples from the typhoid study to see if we could see the similar differences. And what we found was that in the females, there was a significantly higher level of E-series resolvins compared to the males, and a lower level of leukotriene B4, the inflammatory mediators in the females. This immediately suggests that the changes we saw in FMD could be reflected by the resolvins and inflammatory mediators present here. So in conclusion, and in summary, males show a trend towards worsening FMD following an inflammatory stimulus. Females exhibit slightly improved FMD response 8 hours after the vaccine. Although both sexes responded similar in terms of their inflammatory response to the typhoid, particularly in terms of the neutrophil count, there was a reduction in the activation markers in the females, but a better exposure of specialized pro-resolving mediators, suggesting that females might resolve better. So in conclusion, female sex protects against endothelial dysfunction induced by acute inflammation, likely via accelerated resolution inflammation. I'd like to thank my supervisor and PI of the study, Professor Lawalia, members of the group, and all the healthy volunteers in the study. Thank you very much.